Alright guys, so I'm going to go over this quiz review with you guys in preparation for your quiz. That's this Tuesday, January 14th. Alright, so like I had said in class, you're going to get maybe about 5 or 6 problems. A couple of them are going to look like numbers 1 and 2, where we want you to describe and graph the transformation. Right, so you're not just going to see quadratics, right? So I know chapter 3.1 was quadratics. You're not just going to see quadratics when it comes to graphing using transformations, right? You'll see quadratics when we want to find the vertex, axis of symmetry, and all that, right? But for these kinds of problems, we could give you any kind of function, right? And you should be able to graph it. All right, so for number 1, let's look. The parent function is this x squared, right? We know it's a quadratic function. So, in general, it's going to look like this parabola, right? I'm going to quickly sketch it out. All right, so it's going to look something like that. And just a quick sketch. And then this plus 3 is on the outside of our x squared, so this is a vertical shift. All right, this is up 3 units. All right, so take your entire parabola, go 1, 2, 3 above the x-axis, and you're going to go right there. And it's going to look something like that, all right? And that's all you have to do for that one. All right, same thing with this next one. All right, let's see what kind of transformations we have here. First, note that this is an absolute value function, right? Our absolute value function was kind of strange, right? It was the only one that didn't have any sort of curve to it, right? This is a strict V shape. Right, and also notice what's being done to our absolute value of x. We have a -4 on the outside, right? Again, if it's on the outside, it is a vertical shift. Right, and this one's going to be down 4 units. All right, we also have a -7 on the inside. Remember, when it's on the inside of your function, right? I know we typically say parentheses, right? Treat your absolute value like a parentheses. Right, so you're going to have something being added or subtracted on the inside. This is a horizontal shift. All right, so this is a horizontal shift. And since it's -7, it does the opposite of what we think it's going to do, so it's going to be to the right 7 units. All right, so let's take this V shape. We're going to go down 4. 1, 2, 3, 4, and we're going to go to the right 7. 1, 2, 3, somewhere right there. And it's going to look something like that. All right. Now let's do the same thing for this one. So you'll have one problem where we just want you to describe the transformations, right? We're not going to have you graph it, but there's one that you just want to describe the transformations. That might be for a bigger problem like this one, right? So this one, to graph it using just the transformations, is going to be a little bit time consuming. All right, so we might just ask you to describe it, but I'll show you how to graph this one as well. All right, so first identify any shifting, right? So we have a +2 on the inside, right? That is a horizontal shift. And a +2 is going to mean it's going to go to the left 2 units. And we have a +1 on the outside. This is a vertical shift, and it's going to go up 1. All right. Also notice on the outside we have a negative, right? This negative is going to be a reflection over the x-axis, right? So if the negative is on the outside of your function, it's always going to be over the x-axis. Also notice that we have a 1/2 on the outside of it, right? If we have a factor that's multiplying our function, this is going to be a vertical. It's going to either be a stretch or a shrink. Since 1/2 is less than 1, this is going to be a vertical shrink. All right, and it's going to be by a factor of 1/2. Right, if you just say by 1/2, right, I know what that means, that's fine, but you can say by a factor of 1/2, right? So I'm just going to go ahead and write that. I'm just going to say by 1/2. And now to graph it, using the transformations to graph it might get a little bit tricky. So I'm going to make a table of all your x and f of x values. Right, so I'm just going to pick a couple values. I'm going to pick maybe -2, 0, 1, 2, right? So just some random points, right? Relatively small numbers. And let's see what that does. All right, so we get a -1/2 times -2 plus 2 cubed plus 1. All right, this is going to get us -1/2 times 0 cubed plus 1, and that's just going to get us 1. All right, so that means at -2, we have a point at 1. All right, so something like that. All right, so at 0 now, we have -1/2 times 0 plus 2 cubed plus 1. This is going to be -1/2 times 2 cubed. And 2 cubed is 8. So we get -1/2 times 8 plus 1. And that's going to get us -4 plus 1, which is -3. So at 0, we have a point at -3. 1, 2, 3. -8, we can maybe pick another one, so at 1. So at -1/2, we have a point at, okay, so 1 plus 2 cubed plus 1 is going to get us -1/2 times 3 cubed plus 1, and 3 cubed is 27. So we get -1/2 times 27 plus 1, and we get -27 over 2 plus 1. And then converting this is going to get us a 2 over 2. So we get -25 over 2, which is -12.5. All right, so it's going to be way down there. It's probably going to go off our graph, so why don't we go in the other direction, right? So I'm not going to use 2 anymore. How about I use -1, right, to make it a little bit easier, right? So I'm going to do -1/2 times -1 plus 2 cubed plus 1. And -1 plus 2 is 1, so we get -1/2 times 1 cubed plus 1. And that's just going to get us -1/2 plus 1, which is 1/2. All right, so a lot easier point to graph. So at -1/2, we have a point. And that's enough to graph. Just because we know what a cubic function looks like, we know that this is going to originally look something like that. Right, but since we reflected it over the x-axis, it's going to turn into something like that, right? And so let's go ahead and connect these points, right? So something like that. And then we can maybe pick another one. So if you wanted to try -3 just to know exactly what it's going to look like, that's fine. But at this point right here, at this -2, 1, also notice that that's where we make our vertical and horizontal shift, right? So it's going to be in the center, right? So this is kind of the center of our cubic function, all right? But like I said, so for something like this, we might just want you guys to describe the transformations instead of actually graphing the whole thing, right? Because it is a shorter quiz, but you'll have questions that require a lot more work, right? And so we'll give you maybe a question like that that's going to be worth a little bit more points, right? But for something like this, we don't want it to take too long, right? So we might just have you describe it like we did up here. All right. You'll get a question like this where we give you a vertex and we give you a point that it goes through, and you're going to have to write the equation of the parabola in standard form. Now again, we're going to specify in what form we want it in, right? So you won't have to guess. Let's label any information that we have. Right now we have a vertex. Keep in mind a vertex is written as an ordered pair h comma k. And this point we can just label as any arbitrary x and y. Right, so let's go ahead and plug this into our vertex form. And we're going to have 3 equals, we don't know what a is, right? X is 2 minus k, or h is 1, squared plus 0 is going to get us 3 equals a times 1 squared get 3 equals a times 1, which is a. So we get a equals 3, and then all you have to do is plug that into our equation in standard form, right? So including h and k and a, our equation is going to be y equals 3 times x minus 1 squared plus 0, but if anything is adding, or no, if you're adding 0 to anything, it doesn't change the value. So we can just leave it like this, right? And that's our answer, right? Super easy. All right, and then we'll have a problem like this, right? Just one, where you have to graph given either quadratic form or in vertex form, right? So this is an example of a problem in quadratic form, right? So you should know how to do it both ways. In the next page, you'll see one in vertex form, right? But in quadratic form, to find the vertex, all right, let's go ahead and label these A, B, and C, right? So A is 2, B is 6, and C is 4. And then to find our vertex, we get our H value as negative B over 2A. All right, and negative B over 2A here is going to be negative 6 over 2 times 2, which is negative 6 over 4. So a negative 3 over 2. All right, and we'll try to avoid fractions. Right, in this problem, you do get a fraction, but we'll try to avoid that for your quiz. So we get an x-coordinate of negative 3 over 2, and to find our y-coordinate, you want to plug that back in, right? So k is going to be whatever f of h is. All right, so let's plug that in. We get 2 times negative 3 over 2 squared plus 6 times negative 3 over 2 plus 4. All right, and that's going to give you 2 times 9 over 4. Remember that when you square a fraction, you can just square the top and square the bottom, right? And 3 squared is 9, 2 squared is 4. And then plus 3 times negative 3 over 2 is going to get you a negative 18 over 2, right, plus 4. And then you can simplify this however you want, however is easiest for you. A lot of you, what you might do is do 18 over 4, right? So you might multiply this whole number with the numerator, that's fine, minus 9 plus 4. And then you get 18 over 4 minus 5. And then from here, I would try to simplify that fraction more before trying to find a common denominator. Right, so then you can divide the top and the bottom by 2. So we get 9 over 2 minus 5. But minus 5 we can change to have a denominator of 2, and it's going to be minus 10 over 2. And that's going to get you negative a half. Right, so our vertex is going to be at negative 3 over 2 and negative 1 over 2. Right, so I'm going to go ahead and plot that point on the graph, right? So negative 3 over 2 is going to be right here, and negative 1 over 2 is going to be right there. So we get a point right there in the middle. All right, so a little bit tedious, that one, to find the vertex. Again, we'll try to avoid fractions for your quiz. But the process is going to be the same every time, right? Negative b over 2a for your x value, plug it in to find your y value. And as soon as you get your vertex, the axis of symmetry should be super easy. Right, so we just get x equals whatever the x-coordinate of your vertex is. So in this case, it's negative 3 over 2. Right, and always write it as an equation of x equals, right? Otherwise, you could lose points. So our axis of symmetry is going to be this imaginary line right here. All right, and now let's find some more information. For your x-intercepts, you want to set this function equal to 0 and solve. All right, so I'm going to go ahead and do that down here. All right, so I'm going to do 2x squared plus 6x plus 4 equals 0. All right, so you can take out a GCF. In this case, I would divide everything by 2. All right, so that we get x squared plus 3x plus 2 equals 0. And now this, thankfully, is something that we can factor, right? So we're going to get something like x plus 2 times x plus 1 equals 0. And then we get x equals -2 and x equals -1. All right, and then writing our x-intercepts, we want to write them as ordered pairs. All right, so we get -2, 0 and -1, 0. All right, so let's plot those 2 points on our graph. All right, and then our y-intercept, in this form, finding their y-intercept is very easy. You're just looking at your c value, right? So it's going to be 0, 4. All right, and then you can plot that point. And I noticed I made a mistake. All right, so this vertex shouldn't be right there. All right, so it was -3/2 and -1/2, right? So it should have been down there, right there. All right, so it should be facing up, right? And then your y-intercept, we had said, was at 4, so it's going to be right there. And then this is really all the information that you need. You can use symmetry to find the other point, right? So notice that we're 1.5 points away from our axis of symmetry, so we can go 1.5 units away on the other side so that it's perfectly symmetric. All right, and then we get a parabola that looks something like that. All right, and that's all we're really going to ask you. And with domain and range, right, so I think that's the one thing I didn't go over in the lesson, right? Your domain for any polynomial function and any quadratic function is going to be -∞ to infinity, right? So those should be easy points. For your range, let's look at the graph and let's see what the range really means, right? So the range we know means your y values, right? So on this parabola, the smallest y value, remember you're going from the bottom to the top, so going up, up, and up, the first y value that you touch is going to be at this point right here at -0.5. All right, so I'm going to write a little bracket because we're allowed to plug in -0.5 into our function. All right, so we're going to start at -0.5, and then we can keep going up forever until we reach infinity. All right, so that's going to be our range. So notice that it's always going to be the k value. All right, so this right here is the k value of your vertex, right? And it's always going to be the case if it's opening up is going to be your k value, comma, infinity. If it was facing down, you'll see that the range is going to start at -∞, and it's going to go up to and including your k value. All right, good. But that's it for that problem. So it's a little bit longer, a little bit more tedious. And it does require the most work, but that's a problem on your quiz that's going to be worth a lot more points, right? So let's say you knew everything, but let's say maybe you didn't know how to factor it, right? Maybe you couldn't factor it and get the x-intercepts. Then you would just lose points for your x-intercepts, but you'd get everything else right. Let's say, again, maybe you knew everything, but you forget domain and range, or maybe you switch their places, right? And then you lose easy points there. You won't get the whole problem wrong. You'll just get that piece of that problem wrong. All right, so it is worth more points, but there's opportunity for easy points, and then there's opportunity to earn full credit, all right? So let me erase that. All right, so last problem in this review is going to be another graph, but this one's going to be in vertex form, right? So remember, vertex form is in the form of, right, f of x is a times x minus h squared plus k, right? And you do need to remember that for your quiz. Some key pieces of information here. A is just the factor in which we stretch or shrink it, right? But most importantly for you guys, h and k is going to be your vertex. All right, so in this one, if you know that this is in vertex form, then you can get easy points for finding your vertex, right? In this case, it's going to be the opposite of 4 and positive 2, right? So opposite of 4 is going to be -2, or -4, right? And then positive 2. And it's a -4 because on the inside of the parentheses, we have an x plus 4. We can only get an x plus 4 if we plug in a -4 for h, right? Because then we get x minus -4, and that's x plus 4, all right? And then again, your axis of symmetry is going to be super easy to find. Now that you have your vertex, it's going to be x equals -4. All right, so I'm going to go ahead and plot those points. So at -4, all right, so 1, 2, 3, 4, and then 1, 2 is going to be right there. All right. Your x-intercepts, we can set this equal to 0 and solve for x. All right, so for your x-intercepts, let's do -2 times x plus 4 squared plus 2 equals 0. All right, and let's get the square by itself. So subtract 2 on both sides, and we get -2 times x plus 4 squared equals -2. Divide both sides by -2. We get x plus 4 squared equals 1. And now we can square root both sides, and we get x plus 4 is plus or minus 1. And then we can subtract 4 on both sides. We get x equals -4 plus or minus 1. And then we get two answers, right? So we get -4 plus 1 and -4 minus 1. This top one is going to get you -3, and this bottom one's going to get you -5. Right, and so these are going to be the x-coordinates of your x-intercepts. Right, so we're going to write up here at -3, 0, and at -5, 0. Okay, so let's go ahead and plot those points. It's going to be one right there and one right there. Your y-intercept is one where you have to plug in. So your y-intercept, you're going to plug in 0 for x. So we're doing f of 0. And it's going to be -2 times x plus 4. I'm sorry, not x plus 4. 0 plus 4 squared plus 2. And this is going to get you -4 times 4 squared plus 2 equals -2 times 16 plus 2. And so you get -32 plus 2, which is -30. All right, so we get for our y-intercept, we get 0, comma, -30. All right, so that's going to be way down there. What you can do is just change the scale of your y-axis, right? So I'm going to make it go by 5, right? So -5, -10, -15, -20, -25, and -30. And -30 is going to be down here, right? And so, of course, I'd have to change the top as well. So this is going to be 5, 10. That means I can change this to be a little bit more accurate, like down here, right? Oh, my bad. Somewhere right there. Right, and then we have our axis of symmetry right here. So then we have another point 1, 2, 3, 4 units on the other side of your y-axis. Right, so then we can go ahead and connect these points. And there's the graph of your parabola. All right, so again, the other thing is your domain and range. All right, so your domain, like I said on the last slide, it's always going to be -infinity to infinity, right? So that should be easy points. Your range this time, right, notice that now it's facing down. So you're going to start at -infinity, and you're going to end at the highest value on this parabola, right? The highest value on this parabola is going to be at 2. And we are including 2, so it's a bracket, right? And again, notice that we're using the y-coordinate of our vertex. All right? Good. And that's all for your quiz review. I have put some more practice problems in Canvas, right, on top of this, but in general, this is what you can expect for your quiz, right? Something similar to this, asking all of this information, all right?